This video will cover the implementation of the QuickSort optimized for hack assembly. As a first step, I have implemented this sorting algorithm in C++ to get a first view. So at the top, I have included this C as standard library, which contains a swap function. Is in the library that included inside this header file cstd lab. This is input-output stream, which is used in the main function to print out the sorted array. So here is a QuickSort header file, which just the header contains the interface. Let's have a look. It only have one line, which is a QuickSort, the recursive QuickSort function. And then we have a original array, which is out of order, and the size of this array. Below that is a main function. For this, we calculate the end pointer, which is pointed to the last element in this array. So the QuickSort takes two parameters. One is starting point of the array, and the end point of the array. After that, I just use a for loop to print out each element of the sorted array. This is a new convention that I introduced in C++ 17. So for the recursive QuickSort, we have three pointers, which is this period lesser L greater G. So to terminate the recursive chain, we need a controlling condition, which is this one. The substring size is 1, then start to return. In this case, let's assume there's only one element in the substring. The endpoint and the start point are the same memory address. So end minus start is 0, so it is less than 1. Start to return. Otherwise, we'll do this calculation. It is basically the implementation of this loop. Firstly, we put the L pointer to the start point of the array, and the G pointer to the end element. So this one does a squeeze. Oh, here, this one, because the L is at the front, so it first evaluate whether L is less than G, and then do L increment and G decrement. This line is basically the squeeze. After that, we I select G as a pivot here, and then I reset the L pointer and the G pointer to the left and the right end of the array. Here, the swap function from the standard library is used to swap the pivot element and the G element to put the pivot to the end out of the way. After that, the G pointer is decremented by 1 to point the last one except the pivot. So let's start this search and swap loop. Whenever L pointer is at the left-hand side, to the left-hand side of the G pointer, then do this. Whenever the value of L element is smaller than the pivot, increment L until find an element that is larger than the pivot. Then do this. Gradually decrement the G pointer until find the first element that is smaller than pivot, which is 1. So if L is the memory address of the L pointer is still less than G pointer, so do the swap those two elements. Again, evaluate L and G, do the swap, and then increment L and decrement G. This convention is supported in C++, so it saves line numbers. Those 3 lines can be written in one line of C code. Whenever the L and the G meet or crossed, jump out of this loop. So it comes to here. If the L element is larger than the pivot, so swap the L and the pivot, put the pivot into its final correct position. Now, as you can see, the number 4 is at its final position, which splits the original array into 2 subarrays, 2, 3, 1, and 5, 6. So for 2, 3, 1, it goes to this recursive call, which just called this QuickSort function itself, with the start point of the original entire array, but the endpoint is this one, -1, so it is here L -1, which specifies these 3 elements forms a subarray. So for the other array, the start point is L plus 1, L plus 1. The endpoint is just the endpoint of the entire array. So this will repeat recursively until reach the final. Finally, it will reach the array with only 1 element and hits this condition, start to return back. And the final result will look like this. All elements are at their correct location. So let's run this program and see what happens. Build a task. So the build finished successfully. Press any key to continue. Let's clear the terminal and do this debug. So let's put a breakpoint. Okay, the execution pause at this breakpoint, which is calculating the end point of the target array. So where's our array? Here's our array, as I put it here. Why it's different? Okay, the data type is wrong, so let's change it to integer type. Cast to integer type. Okay, now it is correct. 2, 3, 4, 6, 1, 5. So let's do it step by step. Okay, evaluate this one, which is this address minus that address. Is this equals less than 1? Okay, it's not. So continue to do the else condition. Initialize the L and G pointer, which is here, the memory address and the corresponding value, those two. Okay, here select the middle element as a pivot. So we have pivot now, which is okay, pivot 783018. This one. Anyway, let's continue. Okay, it picks 4 as a pivot. So which is the same as expected. So this one should be done after the while. So let's do this. Put a empty loop body. So let's see what happens. This one should be done after the loop. Let's move the breakpoint here. Do the debug again. Okay, let's continue. Remove the breakpoint. Okay, now pivot is 3. Why? Okay, let's let it go to the end. See what happens. Oh, it seems this one isn't good. Can't do this. Anyway, let's remove the breakpoint and execute to the end. Let's see, yeah, this is correct. So what happens there? Not sure. Let's continue to this video and I will have a look later. Break here. swap and see what happens. P and G. P is 4 and G is 5, so it should swap those two elements. Watch here. Watch here. Okay. Yeah, it is swapped. Okay, the next step will decrement the G by 1. So the G decrement from 5 to 4. What here? Okay, it is on this one. So the rest will be easy. Search for any the value from left hand side one by one until it is greater. The value is greater than the pivot. Yeah, this will L increments. And I find the 5. So do the G. G is originally smaller than pivot, so nothing to do with it. Swap. Okay, swap the 5 and 1. So go to the yeah. No. L and G are crossed meets at this point. So escape this loop. Do the put the pivot into its correct location. Okay, the pivot is put into the middle. Now, any element to the left-hand side of the pivot is smaller than it, and any element to the right-hand side is larger. So it will continue to work on divide and conquer to work on this substring. So let's just skip this. Okay, the left-hand side is in order now. So do the right-hand side. Obviously, they are already in order. So, but anyway, need to execute this one. This right-hand branch. Okay, the recursive call is finished. So let's go back to the QuickSort. The rest will be easy. Just print out the sorted array. Yeah, let it execute to the end. Okay, the result is here: 1, 2, 3, 4, 5, 6. So we can check it with other values. This one has 2 large elements. Of course, I'm using 32 bits int. It won't cause any problem. But in the next video, I will show this C code, but it's using the int 16 is more closer to the hack CPU. So it is easier to translate this kind of code into a hack assembly. So back to our original C++ code. That's undefined. Oh yeah, yes. Try this one. Build. Clear. Just remove any breakpoints and see. Okay, this is the result of execution. 1145, 20,000, 22,000. Yeah, even there's a repeated term. My code seems could handle it correctly. So let's try this one with a negative large number. Build. execute. Okay, that's it. Minus 22,000, 20,000, 1145. Okay, the rest would be easy. I will make my code available under the video. Thank you. In the next video, I will talk about this one. The more assembly C code, C++ code. See you then.